good morning students. Myself Dr. Eustace Russell, working as assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So in previous lecture we have completed up to the various classification of gear we have seen. Problems under the gear drives also we have seen using various formulas. In the last video lecture we have discussed about the gear trains, epicyclic gear trains. And that we have seen one important tabular column to solve the problem we have discussed. By using the same concept, today's session we are going to see the same variety of problem in epicyclic gear trains. We will see one by one. So this syllabus already we have discussed. So here we are having one problem, that is a epicyclic gear train. An arm carries two gears A and B having 36 and 45 teeth respectively. If the arm rotates at 150 rpm in the anticlockwise direction about the center of the gear, which is fixed, determine the speed of the gear B. If the gear A, instead of being fixed, makes 300 rpm in clockwise direction, what will be the speed of gear B? That is asked in the question. Here this is the diagram. We are having two gears, that is A and B, fixed with the arm C. The various given data, TA equal to 36, TB equal to 45, and NC equal to 150 rpm, that is anti-clockwise direction. So every time we are going to give one assumption. The 4 steps is there. The first step is normally arm fixed. Gear A rotates to +1 revolution, that is anti-clockwise. If it is fixed means automatically the arm C will be 0 in the first row. Then gear A we are going to rotate with +1 only. So that's why it is +1. So why it is minus TA by TB means, so whenever A is moving in anti-clockwise direction, B will be rotating in opposite direction, that is clockwise. So automatically the sign minus will come. So both are opposite to each other. So that's why the minus TA by TB. And second step includes arm fixed. Gear A rotates to +X revolution. We are going to give some variables, maybe some X. It's not number, some X value. So that's why it is 0. Again, instead of +1, you have to put +X. Why it is minus X means already -1 is there. Multiplying with X, we will get -X TA by TB. Third step remains the constant. We have to add +Y revolutions to all elements, whatever it may be. We have to add with all the, we have to put +Y in all the rows. That is +Y, +Y, +Y. Then total motion. What is the total motion? How you are getting means adding 2 and 3. 0 plus Y, that is Y. X plus Y, that is X plus Y. Y minus X TA by TB. Adding second row and row 3. Second and third. And adding second and third, you will get the fourth row. Then we have to use the conditions. What are the conditions we are going to use? That is important. First condition is, that is given in the problem. Speed of gear B when the gear A is fixed. That is one condition. What is the condition? Means since speed of arm is 150 rpm anti-clockwise, therefore from the fourth row of the table, Y is equal to 150 rpm. Then directly we are taking the value as 150 rpm. Also gear A is fixed, therefore X plus Y equal to, we are going to equate with 0. Y is 0 means because it is fixed only, therefore it is 0. Then X is equal to minus Y, therefore is equal to minus 150 rpm. Then speed of the gear B, NB, Y minus X, TA by TB, 150 plus 150, because how we will be getting 50 means plus 150 means minus into minus plus Therefore, plus 150 into 36 by 45. We are getting 270 RPM. That is anti-clockwise. The next condition is speed of gear B when gear A makes 300 RPM in clockwise direction. What is the meaning of this? Means when the gear A makes 300 revolution per minute clockwise, therefore from the fourth row of the table we can take, because in our assumption we took anti-clockwise as positive, then clockwise will be minus, that is understandable. So that is plus x plus y equal to minus 300. So again we are substituting, the y will go to the right hand side as minus y. So minus 300 minus 150 we will get minus 450 RPM. So upon substituting we will get NB equal to plus 150 plus 510 revolutions per minute in anti-clockwise direction. Next problem, the reverted epicyclic gear train, the arm A carries two gears B and C and compound gears D and C. What is compound gear mean? Two gear fixed in the same shaft. Gear B meshes with gear E and gear C meshes with gear D. We can by reading the problem only we have to draw the diagram. The diagram will not given in the question. The number of teeth on the gear B, C, D are given as 75, 30 and 90 respectively. Find the speed and the direction of the direction of gear C when the gear B is fixed and the arm A makes 100 RPM in clockwise direction. TB equal to 75, TC equal to 30, TD equal to 90, NA equal to 100 RPM. So from the geometry we can take dB plus DE, which is equal to DC plus DD based on the geometry. We can write like that. So under these two dimension of this one, addition of dB plus DE will give this dimension of DC plus DD. Since the number of teeth on each gear for the same module are proportional to the pitch circle diameters, therefore we can use the formula T is, we can directly take the proportional to the teeth diameter, we can take as a proportional, therefore TB plus TE equal to TC plus TD, then TE equal to TB will take to the right hand side, that will become minus TB. Finally you will get 30 plus 90 minus 75, you will get 45. Now we are using this tabular column what I discussed in the previous problem. Always the first assumption is arm will be fixed position, compound gear DE rotated to the plus 1 revolution, that's why arm A is 0 and compound gear DE is plus 1 because that is rotated to the plus 1 revolution. What is gear B? Automatically the transmission will take place from E to B, therefore minus, both are rotating in opposite direction. Then C also the same thing, D, gear D to gear C, both are opposite direction, so minus. Then again multiplying with the term of x, whatever we are doing in all the problems, then multiplying simply with x, 0 into x will be 0, then plus 1 x, then minus x into TE by TB, again minus x TD by TC. Then what is the third step? Always you will do plus y. We have to add plus y revolution to all the elements. Then plus y, plus y, plus y, plus y. Then total motion is nothing but addition of second row and the third row. We are getting the fourth row. So based on the condition, it is given, clearly given, gear B is fixed. Therefore it is 0. Therefore y minus x into TE by TB equal to 0. All the data are given, 45, 75 TE and TB is 75. You will get the value. We will get expression y minus 0.6 is equal to 0. Now we are using the, again the second condition, arm A makes 100 RPM clockwise. So therefore it is y equal to minus 100 because clockwise we are taking as minus. Then substituting simply in the previous equation, we will get minus 100 minus 0.6x equal to 0. In equation 1 we are substituting. So therefore we are getting that value. X is equal to minus 166.67. So speed of the gear is nothing but NC. NC is nothing but the last row, last column expression. Y minus X into TD by TC. Upon calculating the values, substituting the values, we will get 400 RPM in anti-clockwise direction. Now this problem is a sun planet variety problem. This type of problem having a small pinion beam is rotating in the inner periphery of the gear. In this epicyclic consists of 3 gears, that is ABC. Gear A having internal teeth, that is given. Gear C is 32 external teeth. Gear B mesh with both A and C, having both contact. Arm is EF, rotate up to the center of A at 18 RPM. If the gear A is fixed, determine the speed of gear B and C. All the data are given. TA 72, TC 32, speed of the arm EF is 18 RPM. Based on the previous problem, again we have to use the similar tabular column. We can go through it. Based on the conditions, we are going to apply the conditions. One is fixed condition, that's why it is y minus x into TC by TA equal to 0. Upon calculating, we will get 58.5 revolutions per minute in the direction of arm. Then speed of the gear B. How we will getting the speed of the gear? Directly we will not get. We have to basic, already in the previous problem, based on the geometry of the figure, we have to take some data, that is dP plus dC by 2 equal to dA by 2. Again, based on calculation, we can get 2 dB plus dC equal to dA. That diameter is directly proportional to teeth. Therefore, TA equal to 20 we will get. Finally, speed of the gear is nothing but y minus x into TC by TV. Upon substituting, we will get minus 46.8 revolutions per minute. So this also the same thing, the same problem, similar to the previous one, having 2 smaller pinion gears, that is B and C. All the other things are similar. A similar problem, we can go through. You can go through this slide and solve this as the previous one. All the data are given. Based on the geometry, we have to do that first. dA plus dB plus dC equal to dd. We'll get d of A plus 2 dB equal to dd. Then you have to equate to number of teeth. Finally, you'll get TB equal to 25 and TC equal to 25. Again, the same tabular column procedure. We are using the tabular column procedure. In that arm, always arm will be fixed. Wheel A is the first input what we are going to give. Wheel A, that is the input, plus 1. Then transmission A to E. So that is both are same directions. That's why there is no change in direction, plus only. Compound gear CD means again there will be change in direction. So it is minus. So again wheel F is positive, same direction. So wheel B is the product of all this will give, that is TA by TC into TD by TF into TF by TD, that calculation. So based on this we will get the final values. Now the second thing is we have to multiply with plus x throughout the row. The third row is we have to add with y. The finally fourth row we will get by adding 2 and 3. So based on the conditions, we are going to apply the conditions. Y equal to minus 100, that is given in the problem, it is clockwise. Then x plus y equal to 0, because it is fixed only, we are applying the 0 condition. So therefore, x is equal to minus y equal to 100. So finally, you will get 4.2 RPM clockwise. Then the fourth condition is G makes 100 RPM clockwise. So y equal to minus 100. So x plus y equal to 10. Again, condition is given. Therefore, x is equal to 110. We will get speed of the gear, speed of the wheel B. Again, using the same formula from the tabular column. Get the formula from the tabular column and apply the values. You will get final answer as plus 5.4 RPM in counterclockwise. So these are the two references. Kindly go through the references. From these references, I collected the content. Thank you all for your patience. So we successfully completed the Unit 2 with 4 parts of this video lectures. Kindly go through all the lecture videos of Unit 2. I think this will be most useful. Important problems also we have solved, whatever it is asking in the university. So thank you all. Thank you. Mm, Then another one important thing, subscribe the channel, share this video to your friends. Thank you all.